Alright, today we're talking about 6.1, which is solving trig equations. This problem here is a bit of a teaser for what we are going to be seeing later on. So this type of problem is a cannonball problem. However, if we want to figure out what maybe the height of this cannonball after t seconds is, we can use this equation, which we'll talk about later. It's negative 16t squared plus 48t times the sine of theta. So instead of just having a normal quadratic, which you probably learned about in Algebra 1 or 2, we now incorporate some sines or cosines or some trig functions. But we'll get to that in just a little bit. But let's start small. Let's do a bit of review. Let's solve the algebraic equation 5x plus 7 equals 2x minus 5. Now remember, back to algebra, I'm going to get everything with an x on one side, everything without an x on the other side. So let's minus 2x both sides, then I'm going to minus 7, so I end up getting that 3x is equal to minus 12. Divide by 3, and I get that x is equal to negative 4. But what if we want to change things up a little bit? Let's say we have the problem 2 times the sine of x minus 1 is equal to 0. Well, we're going to say this over and over and over again. Get your trig function by itself. So let's add 1, get that over there. So we get 2 sine of x is equal to positive 1. And then divide by 2, I get the sine of x is equal to a half. Now I got to think about what values of x can I plug into sine that make it a half. Well, let's think about my coordinate plane here. I'm looking for the quadrants where sine is positive. So 1, using all students take calculus, my other one is 2. So let's talk about this first triangle here. So sine is opposite over hypotenuse, so I get a 1 and a 2, which makes x squared at 3. Well, hopefully you can recognize that triangle as a 30, 60, 90, with the reference angle being 30. Notice since I'm in quadrant 1, one of my answers is 30 degrees. But we have a second one. We're in quadrant 2, so I'm 30 degrees, that's my reference angle, 30 degrees shy of 180, so I get 150 degrees. So those are my two answers if I'm dealing with degrees. However, if I want to twist to radians, well, we know how to do that. 30 degrees, hopefully remember, is a pi over 6. 150, well, that's just a pi over 6 shy of 1 pi, or 5 pi over 6. So we also have to be very careful in these problems if we're dealing with degrees or radians. And we'll kind of see how we can tell whether we answer in degrees or radians in a little bit. Let's try this. Solve each equation where theta is in between 0 and 360. Notice right away my bounds are in degrees, so both of my answers, 1 and 2 here, have to be in degrees. Well, let's get the trig function by itself. Divide each side by 2. I get cosine of theta is equal to a half. Well, we can think back to my quadrants here. Where is cosine positive? 1 and 4. Using all students take calculus. So let's talk about quadrant 1 here. Well, I know cosine is adjacent over hypotenuse, so my x is a 1, my hypotenuse is a 2, which means square root 3. Again, hopefully you know that as a 30, 60, 90 with the reference angle being 60 degrees. So one of my answers is theta is equal to 60 degrees because I'm in quadrant 1. Then, when I'm in quadrant 4, same idea, same reference angle, which means I'm 60 degrees short of 360. So my second one is 300 degrees. And those are my two answers. We got one more step in this one. We're going to, let's switch colors here. Let's subtract root 3 from both sides. Then I'm going to divide by 2. I'll do those in one step. That's pretty straightforward. I end up getting sine theta is equal to negative root 3 over 2. Now, thinking about my coordinate plane, where's my sine negative? Well, using all students take calculus, I'm in quadrant 3 or 4. Those are my two quadrants where sine is negative. Let's determine my reference angle again. Sine is opposite over hypotenuse, so negative root 3 over 2 with a negative 1. Well, what's my reference angle here? Again, 30, 60, 90 triangle, with the reference angle being 60 degrees. So we can't just put down 60 degrees though. We got to think about this. I have a reference angle of 60 degrees. So I'm 60 degrees past 180, or what is that, 240 degrees for that first triangle. Now I have the same reference angle for my next quadrant. I'm 60 degrees shy of 360, or 300 degrees. So those are my two answers for number 2. So let's solve for t here. Notice I'm in radians, my bounds are in radians, so I have to answer in radians. Now what's different about this problem is, hey, I have a sine t on both sides. So just like if sine t was x, I would get all my x's on one side, everything else on the other side. So we're going to do the same thing. Let's subtract 5 sine t from both sides. What am I left with? Root 3 is equal to, well, this is I have negative 2 sine t. Then divide by negative 2. So I end up getting that sine t is negative root 3 over 2. Hey, notice that this is the same thing. Sine theta is negative root 3 over 2. Sine t is negative root 3 over 2. So I end up getting the same angles. However, notice we're in radians, so I have to switch these 240 degrees and 300 degrees into radians. When we do that, I end up getting that t is equal to, well, I'm pi over 3 past 1 pi, so 4 pi over 3, that's my 240 degree angle. My 300 degree angle is a pi over 3 short of 2 pi, or 5 pi over 3. Now let's check out this one. I'm going to get my sine t by itself again, so negative 4, negative 4. So I get that 3 sine t is equal to 0. Now when I divide by 3, I still end up getting that sine t is 0. So I got to think about, hey, in my coordinate plane, when is the y value on my unit circle? When is my y value 0? Well, if we think about unit circle here, change color so we can see it better. My y value is 0 right there at 0. So my first angle, t is equal to 0. I don't go anywhere. I start at home base, and I have a y value of 0. My next one is, right over here, straight to the left. That's pi. However, because I set up my bounds, including 2 pi, I have to go one full circle again back to home base, and that 2 pi is included in my interval. So I have to include that in my answer. So notice I get 3 answers for this one, 0, pi, and 2 pi, because I included both 0 and I included 2 pi in my interval. So I have to include both in my answer because they're both angles that satisfy this. Let's try a slightly different one. We're going to use a calculator on this one. Again, I'm in between 0 and 360, so my answer is going to be in degrees. And I'm going to use a calculator to solve to the nearest tenth of a degree this ugly mess. Well, let's minus 3 cosine from both sides. Minus 3 cosine. Then I'm going to add 1. So I'm left with 1 cosine theta is equal to 5. Now, if you were to go to your calculator, take the inverse cosine of both sides. I get theta is equal to inverse cosine of 5. You are going to get an error. Your calculator will say error, or domain error, or whatever you want to say. That is because there is no solution here. There's a couple ways you can write this. You can say theta is equal to the empty set. That just means there's no solutions. Or you can write no solutions. You just have to tell me, hey, there are no solutions. There's nothing that makes this happen. Why is that, though? Well, let's do a very quick sketch of cosine of x. 4 key points. This is at 1. This is a negative 1. Now, back to this cosine theta equals 5. Is there any angle, any x value or theta value that I can plug in that will give me a y value of 5? No, because my cosine is trapped in between -1 and 1. That's my bounds. So there is no value where my y value is 5 here, so there are no solutions. Alright, let's review this one. 2x squared minus 9x equals 5. Well, I'm going to get everything onto one side. I'm going to set it equal to 0. So I get 2x squared minus 9x minus 5 is 0. Well, I got to factor this. So hopefully this brings back some extremely fun memories. So I have a 2x on 1 and an x. They have to multiply to 2x squared. Then I need two values that multiply to -5. Well, that's just going to be either -1 and 5 or 5 and -1. We end up getting a -5 on the x and a +1. So we get 2x plus 1, x minus 5, just by trial and error. Now when I have this, I set them both equal to 0 separately. And then solve both of them. This gives me an x value of -0.5. This gives me an x value of 5. So those are my two solutions. Let's do a similar one, where instead of x's, I have cosines now. The process is going to be exact same. Notice, I'm in radians. Good thing to note right away. Get the 5 over here. So we have that 2 cosine squared of t minus 9 cosine of t minus 5 equals 0. Notice this is the same problem as before. However, instead of x's, we have cosines now. But we're going to do the same thing. We're going to factor it. So instead of having a 2x here, I'm going to have a 2 cosine t. If that's confusing to you, set x equal to cosine. Do the whole problem with x's, and then at the very end, switch it back to cosines. Now my numbers are going to be the same. I'm going to have a +1 over here and a -5 over here. And now I set them both equal to 0. So we get that 2 cosine of t plus 1 is equal to 0. And switch colors for this one. Cosine of t minus 5 is equal to 0. Well, okay. On the left-hand side, we're going to find cosine by itself. I end up getting that cosine of t is equal to -1/2. Again, set up your triangles. Since cosine is negative, using all students take calculus, I'm in quadrants 2 or quadrants 3. Let's do quadrant 2 first. I have a -1x value, 2 √3. Same thing, a -√3 though, 2. What's my reference angle there? It's a 30, 60, 90 triangle, with the opposite being square root of 3. So my reference angle is here 60 degrees, or since I'm in radians, pi over 3. So right here, I'm a pi over 3 short of 1 pi. Or I get an angle of t is equal to 2 pi over 3. And then here I'm a pi over 3 beyond it, so 4 pi over 3. Those are two of my answers here for 1/2 of my problem. I still have to do the other side. We'll solve for cosine of t. Okay, cosine of t equal to 5. That's that problem where we have no solutions, because cosine of t will never be 5. So my only answers here are 2 pi over 3 and 4 pi over 3. There are some situations where you could get 4 answers total. You could get 2 for this first one over here, 2 for the second one, and you get 4 answers. However, this time we only got 2. And now for the hard one. We're going to solve using the quadratic formula. Horrible memories, I bet, for you guys. And then we're going to solve this. Remember, we're in degrees. So my a value here is 2. My b value here is -4. My c value is 1. Now normally what you would do is you would set x is equal to negative b plus or minus blah blah blah. However, instead of x's here, we have cosine of theta. So here I get that cosine of theta is equal to negative b, so a positive 4, plus or minus the square root, b squared, 16, minus 4ac. A is 2, c is 1, divided by 2 times a, 2 times 2. That happens when we simplify this down. We get 4 plus or minus the square root of 8 all over 4. Well, 8 is 2 times root 2. So we get 4 plus or minus 2 root 2 over 4. And I can factor out a 2 from all of these. So I end up getting 2 plus or minus root 2 over 2. So cosine theta is 2 plus or minus root 2 over 2. Well, we have two possible solutions here, when it's plus, when it's minus. When it's plus, I get 2 plus root 2 over 2, which if you were to plug that in your calculator, that's about 1.7. Well, I don't need to go any farther than that right now for this one. Why? Is cosine of theta ever going to be more than 1 here? No. So right there, I have an empty set. So I don't need to bother with the plus side. With the minus side, though, I get that cosine of theta is equal to 2 minus root 2 over 2. 2 minus root 2 over 2 is about 0.29. So in my calculator, remember I'm in degrees here, make sure you're in degrees in your calculator. Take the inverse cosine of both sides, so I get theta is equal to inverse cosine 0.29, which your calculator is going to spit out 73.1 degrees. Remember, this is just your reference angle. Your calculator gives you the reference angle. So let's think about where I'm at here. What are the two quadrants where cosine is positive? Using all students take calculus, I'm in quadrant 1 or I'm in quadrant 4. So this is my reference angle here for my quadrant 1. So one of my angles, theta, is going to be 73.1 degrees. Your reference angle. The other one in quadrant 4, I'm going to be 73.1 degrees short of 360 degrees, or 286.9 degrees. And those are my two answers. So just be careful about, hey, where am I at? What's my reference angle? And then just apply it using your quadrants. So go ahead and take a look at this assignment down here for tomorrow, and then make sure you write your summary and any questions you have to get full points.